Hello friends, myself Dr. Pramod Musrif from AISSMS Institute of Information Technology. I am working as an assistant professor in engineering physics. Today we will see the processes involved in the laser, that is absorption, spontaneous emission and stimulated emission. First of all, we should go for the what is light. So light is a wave and having the properties such as wavelength, frequency, period, speed, amplitude, and intensity. Light is an electromagnetic wave, so it has the electric vector and magnetic vector which are perpendicular to each other and perpendicular to the direction of propagation. Laser stands for the light amplification by stimulated emission of radiation. And laser is the device which produces the coherent beam of optical radiation by stimulating electronic, ionic, or molecular transitions. Laser, about the laser, it has been invented by the Charles Stones and Arthur Shallow of the Bell Laboratories in 1950. But the Einstein has given the idea about the laser before 30 years of the invention of the laser while explaining the particle wave duality, and which was, he has been given the name as a measure where M stands for the microwave. In day-to-day life, we are using the lasers in laser printers, laser pointers, etc. Lasing action can be completed by understanding the three processes such as stimulated absorption, spontaneous emission, and stimulated emission. So one by one we will see. This is stimulated absorption. Consider E1 and E2 are the two energy levels. E1 is a ground state and E2 is an excited state. So excited state which is having a very less lifetime. Now if we supply some incident photon which equal to the energy difference between E2 minus E1, then this energy is absorbed by this atom in ground state, atom or molecule or system we can say, and it is going to the excited state E2. So by absorbing some energy, it is going from E1 to E2, that is ground state to excited state, and this process is known as absorption or stimulated absorption. Remember, absorption is always stimulated. Metastable state, it plays a very important role in the lasing action. Metastable state is an excited state whose lifetime is more than that of the normal excited states. The lifetime of normal excited states are 10 to the power minus 8 seconds, whereas lifetime of this metastable state is longer than this excited state, that is 10 to the power minus 3. So this plays very important role in the lasing action. Spontaneous emission, your atom is in excited state, and this excited state is not a stable state. So the atoms, molecules or system will not stay there for longer time because it is unstable. Therefore, it comes from E2 level to E1 level. While coming from E1 to E2, E2 to E1, it gives some photon with the equal to the energy difference between two levels. But this photon is not coherent soul, right? So this is the spontaneous emission. Process is called as spontaneous emission. In stimulated emission, your atom is in excited state, E2 level. Now in this case, we are allowing the system that some photon of energy E2 minus E1 is equal to the energy difference between two levels incident on this system. This incident photon triggers the atom in excited state, and this atom is coming to the ground state. So while coming to the ground state, original photon and the photon due to this de-excitation, you are getting two photons which are coherent and unidirectional. So in this way, the process of stimulated emission, you are getting the two photons which are coherent and unidirectional. These photons, two photons, are same in frequency, same in phase, and same in state of polarization as that of the incident photon, and both the photons travel in the same direction. This process is controlled from outside. As we stop the supply of the incident photons, this process can be stopped. The most important thing is, in this case, the multiplication of photons is occurring. I will just show you that one. In all, we are getting monochromatic, coherent, unidirectional, and amplified beam of laser, which is called as laser. These three processes also can be explained by using the different light like this: absorption, spontaneous emission, and stimulated emission. So your atom is in ground state. So in this case, we have shown this ground state is E2 and excited state is E1. This just changes the notations. Now, if we supply some photon of energy, is equal to the energy difference between these two levels, E1 minus E2, then this photon in ground state will go to the excited state, and which is known as absorption or stimulated absorption. Now this spontaneous emission, your atom is in excited state. This is unstable state, so atom will come to the ground state, and while coming to the ground state, it emits a photon which is equal to the energy difference between these two levels. This is called as spontaneous emission. Now stimulated emission, your atom is in excited state. We are allowing some incident light which is equal to the energy difference between these two levels, and at the end, this photon is atom is de-excited, and at the end you are getting two photons. These two photons are identical in frequency, then phase, and direction. All these three processes can also be explained with these three diagrams: absorption, spontaneous emission, and stimulated emission. The light amplification can be explained. This one photon triggers the atom in excited state, and you are getting two photons. This photon in excited two photons again triggers another two photons. You are getting four photons. These four photons triggers another four photons, and you are getting the multiple photons and light amplification. So in this way, we have explained the processes involved in the lasing action, that is absorption, spontaneous emission, and stimulated emission.